The region R between the coordinates axis y equals 2 to the power of x and x equals 2 is the base of a solid. A volume is formed when R is revolved around the line y equals -1. Set up a volume expression, find the volume on your calculator and confirm that they're the same. So the way that I started first is the stock equation for a washer. And the reason why I believe it's a washer is because when I draw it on the graph, there is empty space between the actual area of the integral and the area that needs to be revolved. Because of that, it needs to be a washer. The formula for the washer is v equals pi times the integral from a to b of f of x squared minus g of x squared dx. F of x is 2 to the power of x minus -1 because 2 to the power of x is the furthest away from what's being revolved, and with y and 2 to the x is the topmost compared to -1, so it's subtracted by -1. And then g of x is going to be 0 minus 1, -1, because that's the second equation below that needs to be revolved as well, and 0 is above -1. A is at 0 because that's where it starts, and then B is at 2 is because that's the start and end points of the graph. So with that in mind, we can plug in the graph to V equal into the equation as V, the volume, equals pi times the integral of 0 from 0 to 2 of 2 to the power of x plus 1 squared minus 1 squared dx. Now, to solve this by hand, first I'm going to need to make the factored form of each equations into their standard form. With that, I could do the FOIL or box method right here. So we have 2 to the power of x times 2 to the power of x becomes 2 to the power of 2x. 2 to the power of x times 1 is 2 to the x. 2 to the x times 1, 2 to the x, and then 1 times 1 equals 1. That random out is 2 to the power of 2x plus 2x plus 2 to the power of x plus 2 to the power of x plus 1. And then the subtracted by 1 comes from right here up as 1 squared just equals 1, and the negative's on the outside, so it stays negative. When we combine those, we can cancel out both the 1's, so we can remove those. 2 to the power of x plus 2 to the power of x is also the same as 2 to the power of 1 plus x, and then 2 to the power of 2x is also the same as 4 to the power of x. Then we can simplify that down into this integral, pi times the integral from 0 to 2 of 4x, 4 to the power of x, plus 2 to the power of 1 plus x dx. We can then integrate that. When we integrate that, we get pi, since it's on the outside, times the integrated from the inside, 4 to the power of x over ln of 4, plus 2 to the power of 2 plus x over ln of 2. And that's evaluated from 2 to 0. We plug those in, we get this, pi times 4 to the power of 2 over ln of 2 plus 2 to the power of 1 plus 2 over ln of 2, subtracted by pi times 4 to the power of 0 over ln of 4 plus 2 to the power of 1 plus 0 over ln of 2. We can all simplify that. 4 to the power of 2, 16 times pi, we get 16 pi over ln of 4. 2 to the power of 1 plus 2 is 2 to the power of 3, making that 8, times the pi becomes 8 pi over ln of 2. The negative we can distribute to both of these, and then we get 4 to the power of 0 becomes 1, times pi is pi over ln of 4, and then positive 2 to the power of 1 plus 0 is 2 to the power of 1, making it 2. Distributed with the negative pi becomes negative pi over 2. We can then simplify that with the like terms. The pi over ln of 4 can combine with 16 pi over ln of 4 to get 15 pi over ln of 4, and then 8 ln of 2 can combine with the 2 pi over ln of 2 to become 6 pi over ln of 2. When I plug that into the calculator, I get 61.186. And then when I plug the integral as well, I get 61.186. Here is it on Desmos, and if that's not allowed, I also have it on my calculator. That's it.